Okay, so just a quick announcement. Finally, we got back our screen. Everything it's the back cable actually, the wiggling. So probably I have to try before they fix it. So I released a few hours ago for homework assignment number 1. You should already got this document. Not only it has all the link, but also this homework assignment is exactly the same as what I did last year of ecs36b for fall 2020. There are two purposes of this assignment. Number one is get you kind of familiar with the Unix environment, a few tools that I actually posted there with some what I call it, some tutorial link. And also I provide a video. There are a few video I put in the assignment you can see here. For part 1, I have 2 video. That's one recorded even earlier, but one is recorded last year. And also for part 2, I want you to, this is nothing to do with C++, but I want you to start refresh your memory about how to do C. So the part 2 is split and heal, the break and heal, sorry. Is how do you take a big file, you actually chop it into smaller chunks, and then you send it over there, and then you try to put them together. I mean, how many of you have used a software called BitTorrent? Some of you use BitTorrent. BitTorrent is a facility for us to share some content. So this is essentially like a BitTorrent or is a mini BitTorrent that you actually break a big file into small chunks and you send it and you actually try to heal the back. Okay, so for part 2, I also have some video. You can see I have 2 video here that's actually included in the assignment. If you go to Canvas, you look at the document, it has this 4 videos, 2 for part 1 and 2 for part 2. So that's our assignment number 1. But in the discussion hour or office hour, we can actually look into that as well. But first, try to work on homework assignment number 1 this way. I do want to say that I set the deadline because I know it's the first homework assignment. I want to give you 2 weeks for most of you. But for those of you, I know some of you didn't take ecs36b A or equivalent in C, in programming language C. So you probably need more time. So that's why I said you'll have a different deadline, but not too far from that because I want you to catch up so you can catch up the rest of the curriculum. So if you have any concern about this homework, please let me know as early as possible. Okay? Any question before I start my lecture? Okay. Okay, so this is my first technical chapter. By the way, all the slides will be online, so you can download it later. So today I'm actually going to talk about 3 things. In fact, I'm going to talk about a whole quarter about these 3 things. So the first thing, of course, I want to tell you, I actually started this a little bit already on Wednesday, is what is object-oriented. Sometimes you will hear me use the term OO, okay? So it's object-oriented. When I say OO, it's actually object-oriented. OO principle means object-oriented principle. So what is OO? What is object-oriented and why? That's the first thing I like to go over. The second thing is that there are a few computational concepts in OO. So we know object-oriented can help us to solve certain problems, but what are the key technical concepts that we need to learn in order to realize the idea of object-oriented? So that's the second thing. And the third thing is that, well, we know the concept, we know why we want to do that, but then we have to really realize in a computer platform. So this is essentially how do we implement this concept in a particular programming language. For example, in this quarter, we're going to exercise how do you actually realize object-oriented using a programming language called C++. But as some of you might know, you can actually do object-oriented in any other programming language as well. You can do it in Python, you can do it in Java, and you can do it in C as well. In fact, you actually can make the programming language you're familiar with, like C, to follow the object-oriented principle. And then to actually do an implementation that's actually object-oriented. Okay, so that's the three things. You can see I tried to cover the three things, but pretty much the whole quarter is about the three things. So we will repeat, go into this concept of going deeper and deeper, and see each of the concepts in depth. But right now, I'm just starting to give you a feeling and start to, yes, please come in. Yeah, sleep, just come into each of this, that's what I want to do. Okay, I mentioned about object-oriented. Let me actually go back to this picture. So there are two reasons. In fact, there are two reasons why we want to do object-oriented. One perspective is from the software development perspective. We want to do a better job in developing software. That's the first reason. And the second reason is that we want to tackle a real-world complicated problem. Okay, so those two are not conflicting with each other, but this both contribute to how and why we develop this idea called object-oriented. So first, let's talk about software development. So in software development, if you use a programming language like the traditional procedure language, such as C, such as Fortran, such as many other languages like BASIC. So those languages were developed probably before 1980. Okay, they developed a lot of that. Some of this is still in use. So you can see that in this language is usually one big chunk of code, maybe 2,000 lines of code. And it has a lot of what we call control flow jumping. From this place, you go to the other place, and from here, you have a very complicated logic in that 2,000 line of code. And there's a few disadvantages of this approach, of course. So number one, it's really hard to develop anything beyond a few hundred lines of code. I don't know, I mean, when you take ecs36b in C, Python is actually much better, but in C, what is the biggest program you ever developed in C by yourself? How many lines of code? Sometimes we call user term, LOC, lines of code. So how many lines of code you wrote in your programming experience in ecs36a? Anybody give me a number? 300 to 400. Okay, that's already pretty big, right? And sometimes there is a bug. And I actually mentioned like in Linux kernel, just the kernel, not the device driver. Okay, just the kernel is about 2 million lines of code. So you can see that what is a Linux? Linux or similar operating system is operate or being running on an airplane, such as 747. And if you think about there's a million lines of code and sometimes even more, and if there is any single bug, that could be really bad. So that's why we software development, we have really struggling with how do I manage a piece of software that's actually huge. Let's go beyond what you have. So that is why we have to do a better. I mean, by the way, C is in some sense people say C is a horrible language because C has this concept called pointer. And by the way, there are other languages has pointer, but not as bad as C. Okay, I discriminate C programming language. Okay, just to let you know that even though that's the language I use for maybe 30, 40 years already. I wrote my first C program in 1983, just to let you know. I was an undergraduate student then. I was just like in your seat, I learned this language. And pretty much I was impressed by the capability in C that a number can be treated as an address and can be treated as a, what's the three thing? There was a three thing. Okay, now I know there's three things. A number is a number. You can add whatever number, but you can treat it as an address, memory address in C, and you can actually add it to that. And then they can treat it as an array. So in C, they kind of mix these three concepts together, which is, I feel, is very powerful for me as a programmer, because I develop everything just using a number. If I want to manipulate an array, I just operate arithmetically on this number. So, but that confused a lot of things, especially think about, we have a room of maybe 150 programmers in this room, and somebody here develop a code using one paradigm and try to have the other person sort of extend it to do something. It's hard, okay? So that's one side of the object-oriented is trying to do, how do you make the software development a lot easier, okay? So there's the other side of OO. I'm not going to get into this, but this is some of the illustration that pointer can be done really complicated. Okay, besides, unless you really careful to count how many parentheses you have, how do you do casting? By the way, C has another thing which is so beautiful. I say it's so beautiful sarcastically. Is called casting. Okay, you can casting it. In fact, in C++, this is actually a bit worse. I want to tell you that in C, when you casting it, when you do the casting, I don't know if you know, this is in C, some of you should know in ecs36b, this is called casting. But in C++, when you casting, you actually change the value of the item that you actually casting into. So in C, you do whatever casting. You're casting from integer to a pointer to a character, the value won't change. But in C++, it will change. In fact, I will ask you to do one homework assignment is specifically look at how things get complicated when you look at C++. So I have to say that it's good for you to learn C++, but in real world, there is some application, I think C++ is very suitable, but there are some application that's actually C++ is not necessarily the best choice. So we have to be open-minded. Even in this class, we're using C++ as an instructional language for learning the object-oriented concept. And I want to emphasize in day one that you can actually apply this concept to any other programming language, like Python, okay? All right, so the second side of the OO is really try to solve a more complicated problem. So when we want to deal with, say, an airplane or a society, because, for example, Facebook, what is Facebook doing? Facebook is trying to connect people. They try to actually model each person as a computational concept, as an information. So we will be able to help people, billions of people, to actually connect with each other. And you can think about any real world problem. The number one thing you try to deal with is how do I convert that real problem out there into something computational? When I say computational, means that I have to not just vaguely, qualitatively describe a concept. I will be able to quantitatively specify every single characteristic of this particular entity I would like to model. So that's actually called object-oriented modeling. Object-oriented modeling, in some sense, is trying to see how you can turn a person, an aircraft, or a component of an aircraft, or some kind of characteristics of something we don't even know how to model it computationally, into some kind of data structure. And that data structure in ecs36b is called an object. So essentially what we're doing to solve the real world using object-oriented principle is that we need to learn how to see the real domain. We try to apply this. And how do we best represent that domain we try to deal with using the object-oriented concept that you will learn in this quarter. So essentially, we're not teaching you how to do that because that really have two things. Number one, you have to know the domain. Number two, it takes experience for you to do that. In fact, I want to tell you that when you apply this kind of concept, you're usually not work by yourself as a programmer. I assume most of you, I think every single one of you are computer science major. And the important thing about this class is that when you go outside of UC Davis, when you go into industry, government, or whatever place to contribute to the society, you will be working with a person from another discipline. Maybe that person is a mechanical engineer. Maybe that person is a social scientist. Maybe that person is a medical researcher. And they're looking at so many different kind of domains. And the thing is that you need to work with them and apply what you learn here in our program is such that you can convert their complicated domain into something computational. And then you will be able to solve the problem together. So this is the second thing. I mean, I like to emphasize this, to be honest with you, is because I have seen a lot of people, when they learn this subject, they focus too much on the first one, software development. I mean, that's important to help you to write the code such that aircraft won't drop, and such that you will be able to solve problems in other domains. But the thing is that I also want you to be really important in order for you to be really, really valuable, contribute to our society, that you need to work with interdisciplinary. So that's why in this course, at the end, by the way, if you haven't figured out, we don't have any midterm, we don't have any final. And homework assignment is very critical of your grade. And number two, I will have a final project. Because final project, I'm going to group you together. We're going to meet a lot. I'm going to show you what final project looks like. I actually record their final project presentation from previous class as well. With their permission, I'll be able to let you see what's coming. Okay, and that's kind of in the final project. I really ask students to put all the pieces together. Right. So that is the first thing I want to talk about. Is called what is object-oriented and why. So now I'm actually telling you why. I haven't told you the detail, which is the second bullet is the basic object-oriented concept. So I want to show you that there is a few words. So since you start to get the vaguely picture about what object-oriented is, I want to just tell you that object-oriented is not just object-oriented programming, object-oriented languages. Okay, those are the linguistics about programming that you use Python, you use C++, Java to write a piece of program. But there are two other factors here that kind of balance the picture about the two sides. The first one is object-oriented analysis and modeling. The second one is object-oriented design. That's complete the whole picture about the object-oriented concept, because you need to actually using the object-oriented paradigm to look at the problem you try to solve, to provide the right level of abstraction for the information. Ultimately, you're not solving the real problem, but what you're trying to solve is you try to model that real problem into some computational concept. When I say computational, I really say you digitize those things into information. Once you can digitize things into information, then essentially you can do whatever you want. I'm going to take out this. It's really hard for me to speak with this. Okay, I just keep hearing my own echo. I don't really have experience using wearing a mask and try to do lecture. Yeah, it's kind of a bit funny. Sorry about that. And after you did analysis and modeling, then you're going to do design, object-oriented design. Object-oriented design is essentially just like a software design, that you know what your goal is, and you want to convert that into a design such that you will be able to easily convert that to a object-oriented program. Okay, so those are the concepts. All right, so I'm going to start showing you some examples. So this is why, just summarize what I have talked about. This is what I have tried to emphasize is about both the software development and the complexity of the problem itself. I'm going to skip the Facebook information. I just show you a few information because this is something which is important. So if you look at a Facebook page or any kind of web service, Twitter, they're the same. Discord, they're the same. Okay, so the thing is that when you really think about this is you see this nice user interface. You see that how people can interact information. But the thing is that you're really looking at is there object flying among those people. So think about communication. The communication in real life is I talk something, you talk something, and then I actually respond. Or I click like or reaction, whatever. So that is really what happened in a real life scenario. In the design, you want those things to happen. But in real implementation, it's about how we are exchanging the information. In fact, those information is being modeled, implemented as an object. So the most popular object representation is called JSON, JavaScript object notation. In fact, JSON is a perfect example of object-oriented principle. It's actually defined. This is really just an example of a JSON representing the page I just showed you previously. In fact, if you have time, go to your web page, visit Facebook or Twitter or Discord, and then you try to look at the source code about that page, you will see a lot of JSON. It's basically today's web is either the mixture, not either. It's a mixture of XML and the JSON. So usually when I talk to people about what's today's world is that when the web client talks to the front end web server is XML and JSON. But when the front end web server talks to the back end web server, everything becomes only JSON. So you can see that JSON is so important. JavaScript object notation. I actually started pushing you to know this concept. Some of you probably already know that since homework assignment number 1. In fact, homework assignment number 1, you can do manually write a JSON to send it to your server. And why is that? Let me just share with you, encourage you why this is important. The first time I taught this class, there were students kind of friendly challenging me, saying that, well, this course is about C++, and why do I need to learn a lot about JSON? And then later that quarter, a different student told me that he actually interviewed for an internship position in Silicon Valley. And basically they ask question, everything is about JSON. Okay, so it's actually quite useful because industry is using that. It's not just use JSON, but using programming language to manipulate, to create, to parsing JSON in order to do real information. So basically in real world, that's what's happening is JSON. So that's just give you some example. All right. So now I'm going to start to talk about the object-oriented concept. So this fourth thing capture the core body about ecs36b. Data abstraction, polymorphism, inheritance, and encapsulation. This basically capture in your textbook, chapter 11, 12, 13, and 14. Those 4 chapters. I thought I have it somewhere here. Let me actually just see whether I have it here. Yeah, I forgot. The textbook is too heavy, so I didn't actually carry it with me. But the first chapter you should be reading right now, I believe is chapter 11. Chapter 11 is about class, which is data abstraction. Okay, so I'm going to start talking about object-oriented principle. You can see there are 4 major principles in every single object-oriented language. And the first principle is called data abstraction, or how do you actually define a class? What do I mean by class? Okay. All right, before I continue, any question? Yes, please.
When should we read chapter?
Right now. Yes.
Okay.
Yeah, you should be able to read. So let me give you a background. You probably want to read chapter 1 as well. You probably want to read chapter 1. But after chapter 1, the whole block of chapter 2 to chapter 10, those are essentially, the concept is not core to the object-oriented. It's essentially repeat to what you learned in ecs36b. For those who actually didn't learn C language, then I will give you more hint about how you can catch up the difference. But for those, most of you, you should directly read chapter 1 and then jump to chapter 11. That's consistent with my practice. And there are certain parts of chapter 1 to chapter 10 that might be relevant, and I will jump back to tell you to read that. For example, I need to talk about how to implement virtual function. There's an important thing called polymorphism. Polymorphism will imply something called virtual function. And the thing is that for virtual function, I have to talk about what we call pointer to function. I mean, for those C programmers, you all know about pointer in C, right? Do you know something called pointer to function? Okay, that's some of you know, some of you don't know, because it's not so popular, but it's so important in terms of the implementation that your function is also an address. So when I say pointer in C, it's really about memory address. You can think about memory address for data, but you should also know that your code, the program is a data, and that data has an address, and therefore, when that address, we call it is a pointer to a function. So essentially, sometimes we have to manipulate that. So let me actually tell you the difference and why polymorphism we need to use a virtual function. That's probably in chapter 7 of the textbook. Is that in object-oriented, polymorphism means that looks like it's one concept, like a different view to the same concept. It depending on some of the runtime information to decide which one of the view I should take. So that's a little bit different from your procedural language. Traditionally, we control everything. So before you input, you already know what's the outcome. You just run it, you get it. But in real world, that's not the same. In the real world, a lot of what we call dynamic binding means that you don't know exactly what you need to do until the runtime. For example, if I want to say AI technology, if this person is introverted person, then I might respond natural language differently than if this is a more outspoken person. Okay, so you can see that you need to do this type of polymorphism computationally. So polymorphism is important. And in order to do polymorphism, you have to do virtual function in C++. And in order to do virtual function, you should know behind it is actually manipulation of pointer to function. Kind of change the pointer from this function to the other function. The program will have a different behavior. So just give you an example for the textbook. So the older textbook, let me just summarize. You should actually start to read chapter 11 as soon as possible. If you cannot understand what chapter 11 is all about, you should let me know. And then we will figure out how to help you to move into that chapter as soon as possible. Okay. Any other question? Thank you for your question. All right. So I'm going to talk about the first principle, which is sometimes we call it data abstraction. And in C++, we call that class. How do I define a class? So what is a class? So a class looks like this. Say I want to model a particular person. Okay, by the way, I feel modeling a person is always the core of any computer science application you try to deal with. Think about all the applications. They pretty much, a lot of them, not everything, but a lot of them have a person involved. So modeling a person, how do I actually model a person? Think about it. How do I model a professor or a student or anybody as a member to a community? That's how we model a person. So in object-oriented, the way we do it is that we try to look at a person, try to see, okay, I know there's a concept called person I want to deal with. So that's why we call class person. But then this person, the way I model it is what we call the attribute. Means that what kind of profiling information I want to have for this person. So think about, oh, by the way, I should ask this question. You shouldn't assume everybody uses Facebook. How many of you never use Facebook? Okay. You use any social media? Okay, good. You're very how do I say that? Privacy sensitive. You don't want to give up any information. Good for you. I shouldn't say that. Probably I have like 6 different Facebook accounts. I just cannot remember which birthday I put in there. Right? That's my research, right? I think it's July 1st or January 1st. I forgot. Whatever they say that. I just do some experiments. Okay, so you think about, for the rest of you, just be careful what information you put in there. If you became my Facebook friend, you actually know all my Facebook friends always say happy birthday to me on a particular day, which is totally unrelated to my real birthday. It's kind of annoying to me. But from Facebook perspective, there's one attribute about me, it's my birthday. It's about my gender. It's about my age, or about, what kind of political leaning I have. So before election, they will send me either some news media to the liberal side or to the conservative side, depending on how they think who I am. So that's what I call an attribute. They basically try to develop, model this attribute, and so they can do some application, right? Just think about this, it's a person. So that's why the number 1 is a attribute. And we'll talk about different kind of attributes. Some of the attribute is called internal attribute. And some of this is called external attribute. Some of this attribute we call inherited attribute. So we haven't talked about inheritance. Remember, there are 4 principles I will cover. Just go back. Data abstraction, polymorphism, inheritance, and encapsulation. Those are chapter 11, 12, 13, 14. So now we only focus on the first one, okay? So when you hear some of the word, it might be just because we're not there yet. But we will deal with what is the difference between what we call the internal attribute versus external attribute. And then this is essentially the data part. I try to have a way to computationally represent a person. You can see that, I can represent myself as a person, Felix Wu, to a very, very detailed, to say, well, what is my blood pressure? What's my DNA sequence? Go down. But really depending on the application you want to do. So that's why this is sometimes no right and wrong answer, depending on what real world problem you try to solve. You're trying to solve a medical problem, you're trying to solve a social media problem. All right. So that's number 1, just represent the data. And the second thing is what we call method or interface. Because if I just have the data, but without defining how to access the data, how to use this data, then this paradigm is not very useful. So it's not just data structure, but all the function, all the operator we need to invoke against those data. That's the second thing. that we need to define for methods. So if you ask me what is a class, what is a class or object? By the way, I'll actually talk about the difference between class and object. You will learn that when you start writing the first program. But essentially, if you talk about the concept class in object-oriented concept, it's just two things. Number one, how do you define the attribute? Number two, how do you define the function or interface to access those data? So that's the basic concept about objects and class. Any question before I show you some real example? All right, good. So usually the way I like to picture is that to be honest with you, in object-oriented, when I do design, when I have a mental thinking about what I'm trying to solve, I usually don't think in the programming language way, like line by line, because I cannot see that. I usually have in my mind, is a picture looks like this. That's an object. So you can see what's the object inside the circle is what we call the attribute. I have to define what kind of attribute inside the circle. So this circle is a object. And inside I have an attribute or the data I want to represent for this object, but also I have some interface. So this is very different from a traditional programming language like C. Programming language C, essentially you have the concept of local variable and global variable. So local variable, global variable, I hope you still remember, in C there is a global variable, there's a static variable, there's a local variable. Those three things are important. Those are still important for C++. So global variable means that anybody can access to this variable anytime, any way you like. Remember I said, not just anytime, but any way you like to access any global variable. Local variable is within a particular scope, within a function or within a pair of curly brackets. And essentially, if you have a piece of code within this curly bracket, you can access to that variable any way you want. And that sometimes confuses us as a programmer, because I don't know what person A is, a programmer A is actually his logic in access that variable when I'm person B try to actually change the code. And therefore, object-oriented make this separation between the data and the interface, or the function, or what we call the method to access that code. So essentially, you can see that I have a boundary. That's called the object-oriented. It's an object as a boundary means that you have to use this method to access this code. Sorry, access this data. You cannot go in directly from anywhere else in the program. So that's a very important thing. It's a protection of your data because it protects from any other uncontrollable way of accessing the information. And yet it's good abstraction because if you think about this, the person object inside here represent the profiling you want to provide. And over here, you're saying that what is the button that you can push for you to access inside here. Okay, so when you do object-oriented design, before you move on the code I'm going to show you, you should have some way to represent an object in your mind. And then you can actually do that. In fact, I want to tell you that this might be a little bit more complicated than this, is that a real world problem, usually you have millions or even billions of objects. And this object is going to interact with each other. It's not just objects stand alone, because you think about why I design this interface, because I want other piece of code to access this particular object. But guess what? Other pieces of code is also an object. So essentially looking at, in object-oriented programming, you cannot think about it as a one straight line of code with 1 million and then think about control flow. In object-oriented, you focus on each of the object. You focus on how this object is going to interact with others. At the end of the day, what the system is really, you put in billions of objects there. If you design individual objects, they work well, then they should interact with each other very well. So that's the magic that we hope to happen. Of course, it's not always happen as first try. It's always have to do a lot of things to make things work. Okay. All right. So that's concept. I'm going to start showing you some code. So this is an example from the textbook. There is a class called Gradebook. No, this is not necessarily the best gradebook, but okay, I'm going to show this example anyway. So this is the first example of a gradebook. You can see syntax here has, let me see, do I have a pointer or something? I'm at the, I know, okay, next time I will bring my own pointer. Sorry about that. So you can see that line number 8 is a definition of a class. Class, gradebook. Gradebook is the name of the class. Class is the keyword. And then you have a curly bracket between line number 9 to line number 16. So inside that, between line number 9 and line number 16, is your declaration for this class. So essentially, that's the body of the class. And inside there, you can see a public. You see that line number 10 says public. So public means that everything below is external. Everything below is something which is other people can access. That's why you have a function, and that function called display message. So I don't know what inside the gradebook. That's why it should have some internal, but it doesn't in this example. I'll actually use a different example. But this particular class only have external. So means that you have an object called gradebook. Whenever you push it, it will actually execute that function called display message, because that's the only external function that you have. And that function will just say, welcome to the gradebook. All right. I'm going to use a more complicated information, not here. 1 second. I know I have the other examples here. Okay. So just, I was looking for this slide actually earlier when I talk about textbook. Can you see that? This is essentially all the textbook chapter. I actually put it on a local server. For some reason, the server, some of you actually told me that the link didn't work. It's not because it doesn't work. It's because there was some VPN restriction. So the engineering building got hacked for cybersecurity reason. So they actually put some firewall. I have to talk to the admin to see how I can let this still be open to all of you. You can see that this is each chapter of the textbook, and we're actually in chapter 11 of the classes. In chapter 12 is overloading, inheritance, and polymorphism. Okay, those are the things we'll be talking about. Those 4 chapters are the core chapter. And I said pointer, that's chapter 6. Sorry, not chapter 7. That's chapter 6. Okay. So one thing you can use, you can go to GitHub. There are examples, every single example in the textbook, in this textbook is actually available. You can actually go over there to download. So in fact, everything I talk about, you can actually just by the way, I put this always in my class, is that as a computer programmer, if you never You have never written the program yourself, you don't know what you're talking about. So if you listen to me just in lecture, you won't learn. You have to get your hand dirty. You have to look at the example, either write your own program or just download this program and try to compile it, try to run it, and to really learn. That's why it's important that I think the programming assignment is so important to learn. Okay. All right. So this is the class. I'm going to show you this example. Okay, this example is called an object, and the object is called a box. You can see that now this is between line number 7 to line number 28. So those are the whole class called box. And inside the box, you have some attribute. The attribute now I call it private. So you can see that now I have 2 different keywords. One is called private, one is called public. So remember I told you about internal and external. So internal is everything under private. Means that you cannot access directly. You have to go through one of the public in order for you to access to the private. That's the basic idea. So I define a class called box, and I define 3 attributes: length, width, and height. And right now, you don't need to worry about the curly brackets, say length 1.0. That's just a initialization. Means that whenever you create an object based on this class, then the initial value is going to be 1.0 for each of this variable. Okay, so you have a 3 attribute. The name of the attribute is the length, width, and height, and the data type of the variable is double. Okay, so that's the 3 variables. That's private, and then you have a public. So public, now I have 2 things. One is I call constructor. One is I call just regular member function. So in this case, I will go for member function first. So member function is actually trying to calculate the volume of this box. So assuming it's some kind of regular shape box. So you can see that the volume of the box is just timed with 3 numbers together. Okay, you can see that you cannot just directly go there to change it or do whatever. But the only things you can do in this particular design of the concept of box is actually just calculate this particular number. And the implementation of the number, you can see that now inside this what we call member function, that I will be able to access to this 3 variable. And then I just type it together, I get the answer, I return. So that's this object is all about. It's a box. It will provide you a particular number, particular attribute that you would like to access. Okay? So this part you can see is under public, but not that one. All right. Any question? Yes?
What does line 17 mean? The syntax is a public. So is it
I will talk about that. I'll talk about that. Yeah. Okay. So right now, what you need to learn is what is a box? Sorry, what is a class? What section of information it has? So now I'm going to talk about something called constructor. I'm actually going to give you the simplest version of constructor. And later you will see there's a lot of variation, a lot of depths that you can actually construct. So what is a constructor? A constructor is a function you need to call to create an object from a class. So now we have to differentiate the concept between what is a class and what is an object. So one simple way to put it this way is that a class is essentially a specification of the objects you really like to model. So essentially it's a design, it's a specification of the object. And the object is a realization from that design. So what I mean is that, well, I have a class here. This is my class. And then I'm actually, based on this class, I'm actually going to create a bunch of objects. And therefore, you need to have a function to invoke that process. And that's called a constructor. So essentially, if I want to create an object box from the class box, then essentially I will need half of this constructor, and the constructor will be called. Right now, you only see one constructor, but in real program, you have multiple constructors, depending on what kind of object, because you can configure differently, you might have lots of different constructors here, okay? So now you can see that this simple constructor take a 3 argument, 3 parameter. Essentially, this constructor in line 15 is essentially just set the initial value for those 3. I already talked about, I said the default value is the 1.0. That's assuming you don't have a constructor looks like this. But if you have a constructor looks like this, then you essentially, when you create this object, that you actually will set the value to that way, okay? All right, before I finish this class today, I think my time is almost up, it's already up, sorry. Give me 1 minute. Now I'm going through 17 to 20. 18, 19, 20 is very easy. I just pass the argument value to my local variable because otherwise you cannot set those values except those public functions. So what I didn't tell you is that inside this public function, in the internal function, when you have this, you already go into that box, go inside. Now you can access that variable. Okay, now we go to line 17, going back to your question. That's actually the C++ way of representing I/O. There is an I/O class. By the way, in object-oriented, everything is class. Everything is object. Not just the things you want to model, but also all the device, all the facility you have. So there is a class called STD. There's a class called STD. Under STD, there's a function called cout. So STD is a class name. Cout is the member function for that class. So when you invoke I/O, it's no longer just say that, but instead, I'm actually call that function and putting this as a variable into that function called cout. That's the C++ object-oriented way of handling the I/O string. That just let you know is, we will not cover that right now, but it's actually in chapter I/O string. Where's I/O string? So that's actually file I/O. It's the I/O string somewhere there. I will dig it out and let you know that. Okay. All right. I will see you on Monday. Have a good weekend.